Okay, so I can't hit hide. I can't hit hide. I lost 2 videos already. So I was trying to show them as they did this by themselves. Then I tried to show the idea of a rectangular coordinate plane. They're right now working on, or supposed to be working on, the next page. So I graph these. I'll erase this real quick, all this red as much as I can, and then put those coordinates back, and then I'll have this reappear. So again, just piggybacking off of what we just said here, here's 2 comma pi over 3. 2 out on the pi over 3 axis. So that red point's right there. But then I erased it, because then the next thing I said is, hey, let's put a rectangular coordinate plane on top of this polar, and then do the next thing that we have to know back. So there's 2 comma pi over 3. And then it comes from Sir Kicks or Ticks, which is cosine of theta equals x over r. So then to get the coordinate in rectangular form that coincides with 2 comma pi over 3, I just insert r and theta into r cosine theta to get the x coordinate. All right, cosine of pi over 3 is a half. Half times 2 is 1. Sine of pi over 3 is root 3 over 2 times 2. That's root 3. So coordinate plane that coincides with this coordinate is 1 comma root 3. 1 right, root 3 up, with a radius of 2. That's your classic 36 and 90 side relationships. So the point of this rectangular coordinate compared to polar coordinate, they land in the same spot, and they're 2 respective different types of coordinate planes. Okay, guys, ready? You should be. Okay, so because again, I told you the unit circle is not going away. What we just did, sine of an over 6 is a half, so cosine of an over 3 is half. That really dictates the 6s and the 3s. If you don't know an over 4 sine and cosine, we got some issues. All right, and that's really the deal. I kind of skipped over 3. All right, you ready? So that's when I gave them this sheet. This is just a 100% reiteration of Monday. Okay, so hopefully this video is working. I've already had 2 errors. All right, ready, set, go. Okay, and I did this real fast, and I can graph like 2 of these. Well, one of them, because the root 3s don't really work, but we can make sense out of letter B. But letter A, 2 comma pi. Well, it's 2 cosine theta, comma 2 sine theta, x comma y. And then just think about this graphically. Here's pi on a polar coordinate plane, and then here's 2 out, 1, 2. There you go, on a polar coordinate plane, that's where we land. Well, of course, on a regular coordinate plane, left 2 is negative 2 comma 0. So that's why negative 2 comma 0 lands in the same spot on a rectangular coordinate plane compared to 2 comma pi on a polar coordinate plane. It's all about locations, so on and so on and so forth. By the way, a term, the origin on a polar coordinate plane is called the pole. Can everyone say pole? P-O-L-E. So the pole is the origin. So when that term comes out, just be ready for it. I'll try to reiterate that over and over again. Now think about 4 comma 5 pi over 3, at least coordinately where it lands. 5 pi over 3 is in quadrants wrong. It's actually closer to the y-axis, but that's not a big deal. So that's where 5 pi over 3, and then imagine you're 4 out. So just imagine, this is why I get 2 comma negative 2 root 3. Right 2, down 2 root 3. You at least should make sense what quadrant you're in when you get your final answers, all right? And that'll help you with errors, like sign errors or whatever. And then how does negative 3, 7 pi over 6 graph? Here's 7 pi over 6, but negative 3 means I go in the opposite direction. So that means I'm in quadrant 1. My answer should reflect that rectangularly. That make sense? All right. So anyway, sine of cosine of 7 pi over 6, cosine of it over 6 is root 3 over 2. But it's negative in 7 pi over 6 for cosine. So a negative times a negative is a positive. All right. And then sine of 7 pi over 6 is negative a half. That's how you get positive. So making sense out of this. And then to reverse it. And I want you to work on this for a second. To reverse it, it's all about this triangle. If I have x comma y, what trig function deals with opposites and adjacent? Who? Or who is x? Tangent. So that's why the tangent function is used to find the angle measure for polar coordinate representation. Then to find r is just the Pythagorean theorem. But then a common way of writing it is get that square root taken care of. So it's a square root of x squared plus y squared. So now you're just doing the exact reverse. Work on the next three. Okay, so work on the next three. Convert rectangular to polar. All right, we'll wait for that for a minute. Third hour, I guess you could do the same. Hopefully this works out. But yeah, it's real bad. We've had 2 days away from each other, and then they're taking me out of a meeting third hour. And then fourth hour is my lunch. I don't know what's going to happen there. I'm going to just bring it and then during the meeting. I'm really going to be loud when I eat too. Maybe burp a couple times. It's a stall factor, all this blabber. Coming to some real good ideas how to finish the year. Those that are taking the AP exam. After our last quiz, we're really going to focus on that right up to the day of the exam, which is a Monday. Extra time to study over the weekend for your AP exam. And then there is going to be a final. I don't know if a video got destroyed when I said that before. Final will just be straightforward. Do you know? No AP-like questions, at least not. There may be one or two we insert in there, but they're just going to be knowledge-based. Give you one last chance for a big charge in your grade. Juniors will take it with the seniors. Did I say that? Juniors will take it with the seniors, the final exam. Okay. All right, here we go. By the way, -2, 2. When x and y are equal, what kind of angle measure am I dealing with? An over 3, over 4, or over 6? It's an over 4. Everyone should have got that inverse tan of -2 over 2, which is inverse tan of 1. There's a problem, though. You better figure out where -2, 2 graphs. What quadrant does -2, 2 graph? Quadrant 1, 2, 3, or 4? 3, 2, 1, go. 2. So your angle measure should be in quadrant 2. What over 4 is in quadrant 2 before I reveal the answer? 3 pi over 4. If you still don't know how to do that, you are severely and totally what, everyone? Behind. So you can't really, because inverse tan of -1, we could get 2 possible answers. You got to equate this to the question. That's why you got to think about this coordinately. You know, -2, 2 is in quadrant 2. Inverse tan of -1 is an over 4. Oh, the quadrant 2 over 4. If you don't do that, you're gone. All right? And then this one ends up, I know someone asked me on, this is a good question. On the video, I'm like, good, you watched it. Nice. On the video, they did decimals. That'd be okay too. I'm just worried about multiple choice. I know us, we'd probably do the exact radical form. But you can type the square root of 8 on your calculator. Anyone do that? Get the decimal for this? Anyone do this one? Did anyone get this answer? Okay. All right. And then this one I just didn't do, but this is in quadrant 4. All right. So 1 root 3. I would know what this is right away. What's opposite root 3? An over 6 or an over 3? What's opposite root 3? How did I say this? Over 3 is opposite root 3. Remember that? Root 3 is opposite over 3s. All right? I don't know. It's one or the other when I tried to do a different way of figuring out these angle measures. So I already know the angle measure. It's 5 pi over 3. That's the only way I can get in quadrant 4. Some of you just look dumbfounded by that answer. I don't understand. All right? These are things that we've been practicing since February 1st. And then what's the radius? It's actually 2. 1 root 3, 2. 2 is the radius back without any math. How many people got 2 5 pi over 3? Not good, all right? This is just really based off of things that we should know from the unit circle. And then really we should know this one without doing anything. 0, comma, -5 is right there. What would that be as a polar coordinate? 5 as a radius, and that's 3 pi over 2 as an angle measure. So you can see how this is tied to stuff we should already know. I don't know. All right, got to move on. This is part of the problem of not getting that unit circle really dominated. All right, and then this is just a little tweak. I know this is weird, but your phone, your life that everyone sticks their face in like every minute of every possible moment would not work without I numbers. I numbers actually are huge in electrical engineering and anything that deals with electricity. So, and that's why A plus BI numbers get pretty large here as far as importance in mathematical structures. So I just want to throw that out there. If you do anything mathematical in college, you'll probably see I numbers. Again, so here's what you learned from the guy on Monday. You also have a thing called an imaginary, actually it's called a complex, my bad, complex coordinate plane. And it really works the same way as what we just did on the previous page with a little tweak. So it's not any longer an X and Y axis, it's a real and imaginary axis. So I know you can see this, but sometimes you don't look at the typing so much because there's a lot of typing. The A plus BI number, 3 plus 2I, is thought as 3 comma 2, where this is the real part, this is the imaginary part. And then you can graph that on in a complex coordinate plane. 3 real part, comma 2 imaginary part. And then they do a lot of stuff with it. Just accept it. This is like wax on, say it, wax off. This is just a thing, and then it's expanded upon as your math career maybe continues. So here's what you do. Instead of writing it as r comma theta, you have to write it in what's called cis format. And I'm going to write this way. And I'll show you why when I show the last ones. I might just take over this and just do notes because I feel like I've gone a little bit too long here. Right below this, I know the guy on Monday did not do this according to First Hour. This is written in this format because mathematicians are lazy. All right, they like to shorten things down. Last year we did this a lot. We did cis numbers like if we ended the school year with it. And all cis means is cosine plus I sine, and then the R is distributed. So I'll show you that as we go. All right, so here's what we have to understand. All right, the way they wrote this, and let's read this, and then I'll zoom into my writing. Don't just start writing and be a note copier. All right, just listen for a second. A complex number is represented by a point in a complex plane. So that means -2 comma -2 actually means, go ahead and write that, -2 minus 2i. That is the complex number. And I don't need parentheses. I don't know why I did that. So -2 minus 2i, A plus BI number, can be graphed in a coordinate plane -2 comma -2. Now, what is one way to express a complex number using polar coordinates? I'm going to do that, but then I'm going to tell you what you actually really have to do. Well, it's simple. You treat this just like the last question. Go ahead and graph -2 comma -2. There it is in a complex coordinate plane. That's where -2 comma -2 lands. Now what I want is, what is r comma theta? So what's theta and what's r? It's the same math that we just did because it's the same exact thing. By the way, what is theta? You should already know it's an over what? 4. Why? Because the x and y are equal. All right. And what is it actually? 5 pi over 4. And then what's the radius? You could probably figure out that it's -2, or no, it's 2 root 2, because the radius is always positive. Remember a root 2? But I also did the math. Okay, but what do you have to do in order to get that coordinate? The r is the Pythagorean theorem. The angle comes from inverse tan. Don't be a robot, though. It's non-calculator anyway. There are some that are calculator, and that requires a little bit different thinking. We'll maybe talk about that. I should maybe throw one of my quizzes. We have a quizzes tomorrow based off of all of this. No, nothing new. All right. because you should be responsible for learning on a daily basis. Otherwise, we can't get anywhere, which has been happening. All right. You got to know that inverse tan of 1 on the calculator would give me a quadrant 1 over 4. You got to know you're in quadrant 3. So it's got to be the quadrant 3 angle. That's just one little extra stretch. But then here's the thing. When I have a complex number that's in the form a plus bi, then I must write this in polar form using the cosine I sine thing. So here's really what I want you to write. This has to be turned into this, because then I'll show you why when we reverse it. Right, so it goes a little against the directions, but I don't like the way the directions are worded and kind of steering you in the wrong way. It's the exact same math, it's just a notational thing. And then I told you, what are mathematicians? Starts with an L, lazy. So they come up with another format of writing this so they don't have to write as much. Every mathematician needs to know that cis means cosine plus I sine. And then the r is in front of each one, and the theta is 5 pi over 4 in this case. I do want to show you that because that should be shown. I don't know why they didn't show you that Monday. It may come up later. Okay? All right, and then just being a note person, okay, here we go. This is why we have to have the cis format. It actually makes your life easier. So now I have to take the cis format. By the way, this is equal to 4 cis 7 pi over 6. It's just a notational thing. You would need to know, okay, that means 4 cosine 7 pi over 6 plus I sine 7 pi over 6. 4, I forgot the 4, right? But that's easy. All you have to do is evaluate. And then you should know at this point, and if you don't, it makes me sad, that the cosine of a 7 pi over 6, cosine of an over 6 is root 3 over 2, negative in quadrant 3. Sine of 7 pi over 6 is 1/2, but negative in quadrant 3. Then you just evaluate. And then you see that, okay, now it's an a plus bi number. That's why the cis format's kind of nice. It keeps me everything in the right format. Then when I reverse it, or was that the end? That's why I wanted to do this one. Reversing it is understanding, your inverse tangent and write it as a cis number. So I didn't really like how example 6 was worded. All right. So the difference between just a regular polar coordinate plane and a complex plane, it's just different notation. That's all it is. It's really the same exact math. That's why they're put together. All right. Hopefully this video is good.